So, in this video, I will be showing you an example of a one-way Anova by hand to illustrate and understand how our computer works in solving the data or samples. Always remember that the goal of our one-way Anova is to compare the means of at least 3 conditions in a particular experiment. So, for example, three I conducted exams in these 3 sections. And these sections takes the same course, the same exam, and I'll just getting the sample of the population. I'll be getting 5 students each section to take the exam, and these are their scores. And we will be calculating the averages of each section. So we have here the 7 for section 1. For section 2 we have 4.4. For section 3 we have 3.6. And we'll be calculating the grand mean, the mean of our means. So we have the 5. The summation of this 3 divided by 3 is equal to 5. So that's how we get our grand mean. Or we can have the summation of all the scores divided by the total number of population. So we will be going to calculate the app statistics, but before that, to answer all of this, we have to specify first our alpha level that we plan to use in our study. So I will be planning to have a 0.5 as in our alpha level, and so this is our significance level or our alpha level. So it is our probability of rejecting null hypothesis when it is true. It answers the question, how far out do we draw the line for the critical region? And I will be stating my hypothesis here. So we have our null hypothesis. The null hypothesis in ANOVA is valid when all the sample means are equal or don't have any significant difference. So if we said that mu sub 1 is equal to mu sub 2 is equal to mu sub 3, so that's our null hypothesis. Now our alternative hypothesis will be at least one of the sample mean is different from the rest of the sample means. They don't all have to be different, just one of them. Okay, so the first that we have to solve or to calculate is to analyze the degrees of freedom. So we have here, this is the formula of the degrees of freedom between is equal to m minus 1, where m is the number of conditions. So how many conditions we have? We have 3. We have section 1, section 2, and section 3. So minus 1 is equal to 2. So that's our degrees of freedom between. And our degrees of freedom within is equal to n minus m, where n is the total number of scores. So the total number of our scores are here, that green area. We have, since we're getting 5 students each section, we have 15 for our n, for the total number of our scores. And since we have 3 conditions, 15 minus 3 is equal to 12. So that's our degrees of freedom between and degrees of freedom within. So we have to analyze these degrees of freedom to determine that critical value using our F distribution table that we will be looking at the end of this video. Okay, so now since we had our degrees of freedom, let's start to calculate our sum of squares. So this is the formula for our sum of squares. So our sum of squares total is equal to the summation of x minus the grand mean squared. So that's the formula. So referring to our table here, our x here is the individual observation. So this one is our individual observations. And our grand mean is 5. So for section 1, we have this. 7 minus 5 squared plus 9 minus 5 squared plus 5 minus 5 squared plus 8 minus 5 squared plus 6 minus 5 squared. Again, in ANOVA, this is the detailed portion in solving datas. So in section 2, we have the same process. 4 minus 5 squared plus 3 minus 5 squared plus 6 minus 5 squared plus 2 minus 5 squared plus 7 minus 5 squared. And for a section 3, the same process. Okay, we have to get the summation of these 3 sections. That would be our sum of squares total. So our sum of squares total will be 74. So you have to take down notes of that value since we are going to use it later. So now we have our sum squares within. So this is the formula, the detailed portion of our ANOVA. So I have the table. So we have this x sub 1 minus the mean sub 1. So in section 1, we have this 7 minus 7 since our mean of the section is 7 and the individual observations would be 7. And this is our group mean of section 1. And this is our individual observations or the scores. In section 2, the same process. So we have here our group mean, which is 4.4. So this would be our group mean. And for section 3, we also have the same process. We have our group mean 3.6 here, 3.6, and the individual observations here. Okay, so you have to sum up, or you have to get a summation of these 3 sections. So in sum of squares within is equal to 42.5. So that would be our sum of squares within. Now let's calculate the sum of squares between, since we now have the total, the SS total and the SS within. So we just have to subtract this the values. So we have here 74 minus 42.5 is equal to 31.5. So that is the value of our sum of squares between. So now let's have to calculate the mean squares between and within, since we now have our SS between and within. So we have the mean squares between is equal to sum of squares between and degrees of freedom between. So this is the value that we had calculated earlier. So we have 31.5 divided by 2 is equal to 15.75. So that's the value of our MS between. In our mean squares within, we have is equal to SS within all over DF within. So this is the value that we had calculated earlier. So we have 42.5 divided by 12 is equal to 3.54. So that's the value of our mean squares between and within. Now we are ready to calculate our F statistics. So that would be our F value is equal to mean square between divided by mean square within. So this is the value that we had calculated. So we have to divide this through. Now our F value is 4.45. So we now have our F value. Now looking back, the degrees of freedom between and degrees of freedom within and our alpha level, we will going to look for our F critical in our F distribution table. So always remember that our between our df between would be our numerator, and df within is our denominator. So we have this one. Please remember. So we'll have to look for the f critical. What? So we have here, since we have the denominator, so we have the denominator of 12 and the alpha level of 0.5 and the numerator of 2. This is the 2. So we have this 3.89. So that would be our f critical. So now, since we have the value of our f critical, which is 3.89, and the f value, which is 4.45, now we are going to interpret uh, our hypothesis and ANOVA test. So since f value is greater than f critical, and as you can remember, our null hypothesis says that sample means are equal, and our alternative hypothesis, or at least one of the sample means, is different. So what we're going to do is, if this f value is greater than the f critical, we have to reject our null hypothesis. Now, so that's the uh, that's the results of our F statistics, that at least one of 3 samples have significantly different means and thus belong to an entirely different populations. So we have to reject our null hypothesis. So thank you.